Good morning, students. In today's lecture, we will be discussing the theories of earthquake. Okay, so by now, I think you are all aware and you have all studied what is an earthquake and some important definitions that I have given you regarding earthquakes. Okay, and also I gave you these three theories regarding the earthquake. One was your elastic rebound theory, second is your theory of continental drift, and third is your theory of plate tectonics. Okay, so in this class today we will be discussing the first two, that is elastic rebound theory and theory of continental drift. So without any delay, let's start. So what is an elastic rebound theory with respect to earthquake? Okay, so generally, in this theory, elastic rebound theory, it explains how energy is stored in rocks and released by earthquakes. Okay, that means whenever there is a earth shaking, okay, so what happens and why that earth shaking is there? Okay, what is the uh, main idea behind that particular type of shaking? Okay, so this theory gives you, or this theory rather tells you how energy is released. Okay, how energy is released, or how energy is released means why there is shaking in earthquake. So this is the one of the most accurate theory which is explained. Okay, so I'll just briefly I will touch this theory. So what it does, it explains you how energy is stored in rocks. Okay, explains how energy is stored in rocks and released by an earthquake. Okay, and released by an earthquake. Okay, so whenever there is an earthquake, there is a ground shaking. Okay, so that shaking is because of a sudden release of energy. Okay, how that energy is present, or how that energy is present inside the rock, so that we will little bit will discuss about that. Okay, so what happens is that whenever, so I'll, with the help of a diagram, I will explain this properly. See, what happens is that, let's say we take two rocks. Okay, and there is a fault line between this. So by now you know what is a fault and what is seismic wave. Okay, by these things, these definitions I have given, so you can go through the definitions and you can be prepared for this lecture. Okay, let's take an example. This is first photo. Okay, there are two rocks. Okay, and then we are seeing a fault line, okay, in between these two rocks. Okay, rock masses. So now what happens is that, so this is the original position. Okay, how the rocks are shaped. Okay, so what happens because of development of stresses? Okay, so what happens, the rocks, they are in continuously, they are pressing against each other. Okay, the rocks, they are continuously pressing against each other. So, and you know that your the earth is divided into various tectonic plates. Okay, so because of this movement, their rocks are always pressing against each other, they are sliding or they are converging, diverging. Okay, so since because of these activities, what happens, they store, or they store a lot of energy inside them, or lots of elastic stress is getting stored inside the rocks. Okay, so since they are storing the energy, so what happens, the shape of the rock starts, the shape, initial shape of, see the observe, you observe the initial shape and position of the rocks. Okay, so after continuous friction, okay, friction between the rocks, okay, and continuous friction between the rocks, and because of continuous this sliding, then converging and diverging motions, the rocks store a lot of energy, or rather stresses are developed inside the rocks. Okay, so better word would be elastic stresses are developed inside the rocks. Okay, and those are getting stored inside the rocks. Okay, now what is happening, the rocks can store as much energy as they can, but there will be a breaking point, right? So suddenly so it's never infinite. Okay, so they can store lots of energy, but there is a boundary of storage. Okay, so after some time, what happens when this storage or this capacity exceeds, okay, then the rocks will suddenly release the energy. Okay, so there will be a rupture and the rock will suddenly release the energy. That released energy travels through the ground, and which results in the development of seismic waves, and finally the shaking of ground takes place, or which we also known as the earthquake. Okay, so original position is that, see now here, this is the original position of the rock. See the second picture. Because of development of these stresses, the rocks, they deform. Okay, so deformation is taking place, but they are not releasing the energy till yet. Okay, so they are storing the energy, so they will keep storing and doing that, but they, what they want, they want to go back to this position. Okay, it's just, I'll explain with the help of an elastic. So this is just like an elastic band. Okay, take an elastic band. Okay, so original shape of the elastic band is the elastic band without any stresses or forces acted upon it. Okay, so now at equilibrium, so now what happened, you pull the elastic band from two sides in opposite direction, then what will happen, the elastic band will it will stress out, right? So there will be stretching movement. Okay, so you will stretch the elastic band, so it will keep on going. Okay, the length of the band will go on increasing up to a certain point. Okay, and that when the certain point comes, if you apply more pressure beyond that point, then what will happen, the elastic band will break off, right? So when it breaks, it again regains its original position, that is before applying those opposite pressure forces. Okay, so similarly this rock, though it is being deformed, it wants to go back to this original position, but now it cannot, because it has already been developing a lot of stresses. Okay, so what happens, suddenly this stress will go on continuing. Okay, so this will go on absorbing, and suddenly what will happen, there will be a release of that energy. How the energy is released, the rock will get ruptured. Okay, so there will be ruptures develop, and then that ruptures will release the energy. So there the final breakdown of the this is breakdown of the particular rock has reached. Okay, so the breakdown limit, this is the limit beyond which the rock cannot absorb more stresses. Okay, so this is the breakdown of the rock. So there will be a rupture in the rock, and then that will release your sudden energy, thus energy which was stored because of those movements. Okay, so that released energy will result in your seismic waves, and which will result in your earthquake. And then when the energy is released from the rock, so the rock again goes back to your original position. Okay, so this is the position the rock wants to be in, but because of the movement of these tectonic plates, okay, so they develop lots of stresses, and that stored energy, okay, that stored energy is getting released. Okay, and this is called as your elastic rebound theory. Okay, see, it is like an elastic band. You take an elastic band, pull the elastic band, original position of the elastic band, when you don't apply, you know, okay, how the band is. Okay, when you pull the elastic band from the opposite sides, two sides in opposite direction, then that band will increase in length. Okay, the length of the band will increase. Okay, but the band wants to, if you release the band at that moment, what will happen, the band will go back to its original position. Okay, but if you don't release, if you go on pulling, a certain point will come at which the band will tear off. Okay, so when it tears, what happens, it releases the energy. Okay, sometimes if you pull it with your hands, so you may get small injury also, right? So that energy is released. Okay, so once that energy is released, the band again goes back to its original position, though it is teared off now, there is a rupture, but then it will again go back to its original unstretched position. Okay, so that is called as elastic rebound. Okay, so it is again elastic. See, elastic, you know why this word is coming, right, from the elastic band. So it is again coming back to original position, and it is rebounding. Okay, the effect is rebounding. Okay, so this theory is called as elastic rebound theory. Okay, so I hope you are clear with this theory. Okay, so briefly I will write some points. Okay, explains how energy is stored in rocks and released by earthquakes. Okay, So energy is transferred to rocks, which results in the shaking of the earth's surface. Okay, so it occurs in fault lines, occurs in fault lines, okay, and earth stores elastic earth crust. Okay, just a moment, let me clear this one out. Earth crust stores elastic stress. Earth crust stores elastic stress and gradually builds up. Okay, builds up and suddenly released, causing earthquakes. Okay, and suddenly released causing earthquakes. Now for example, you take an example. So the famous example of this is will be your San Andreas fault. Okay, San Andreas fault runs through California, is located where North American plate slides past Pacific plate. Okay, Pacific plate. So San Andreas fault runs through California. Okay, runs through California, and located where North American plate slides past Pacific plate. Okay, so that is the best example. All right, I hope you have understood what is elastic rebound theory. Okay, all right, so next let's move on to the next theory. Okay, in this theory just remember the example of the elastic band that I gave you. Okay, so the moving on to the second theory, that is theory of continental drift or continental drift theory. Okay, so this was proposed by German geophysicist and meteorologist Dr. Alfred Wegener. Okay, proposed by German geophysicist and meteorologist Dr. Alfred Wegener, Wegener, Wegener. Okay, so what was the idea behind theory of continental drift? So the idea is, previously you see, now we know we have a definitive map of the world. Okay, so we have a map of the world where there are continents, okay, which are divided by oceans. Okay, some continents they are touching each other, whereas some continents they are divided by the oceans. Okay, so the earth is spread like this now. Okay, but according to Dr. Alfred Wegener, okay, so he believed that the earth was not like this. Okay, the earth previously it was not divided. Okay, so he believed that the earth was one single supercontinent. Okay, so earth was comprised of a single supercontinent, which he called in German as Urkontinent or Pangaea. Okay, so initially earth was not divided, rather it was all the continents were joined together. Okay, earth was composed of earth consisted of one supercontinent called as Pangaea. Okay, or in German it was called as Urkontinent. Urkontinent. Okay, so earth consisted of one giant supercontinent called as Pangaea. Okay, so in that giant continents, all the continents that we know in this current era by the world map, they all were comprised, and they were all joined together. Okay, they were all glued together, and that whole mass was called as Pangaea. Okay, nowadays what is happening, we are having different continents and they are divided by oceans and seas. Okay, sometimes they are also connected. Okay, but earlier this was not the case as per Dr. Alfred Wegener. Okay, so earth was having only one continent. Okay, and all the present day continents that were glued to each other. Okay, how he proved this? Okay, how he gave evidence for this theory? Okay, so he gave 4 evidence. Okay, 4 evidences were presented by him. First evidence was apparent feet of continents. Okay, like a jigsaw puzzle. Okay, so first evidence it gave was the apparent feet of the continents like a jigsaw puzzle. Okay, like a jigsaw puzzle. For example, let's go to this next slide, you will understand this one. Okay, so this is the map of the earth. Okay, so he observed carefully that the continent of South America, okay, if you observe carefully the continent of South America and Africa, okay, they look like they are 2 pieces of a jigsaw puzzle. That means if you join these 2, they will fit very properly. Okay, the fit will be very good. Okay, so because of this, okay, this was one of the evidence, or this was the first evidence, or first thing that he noticed. Okay, they were pieces of jigsaw puzzle. If you join together, then we'll get one continent as a whole. Okay, but this evidence was not very good, or it was not enough. Okay, so he then gave his second evidence. Okay, he then gave his second evidence. So he studied about fossils. Okay, and then he found that there are some fossils which were identical on different parts. Okay, different parts of the world. Okay, for example, let's take an example, mesosaurs. Okay, for example, fossils like mesosaur, MESOSAU, Mesosaurus. Okay, MESOSAURUS, Mesosaurus. Mesosaurus is a freshwater reptile. Okay, it's a reptile which lives in fresh water. So when he observed the fossils of a Mesosaurus, what he found? He found that in the eastern coast of South Africa and western coasts of Africa. Okay, for example, see in this figure. Okay, if possible, let me clear this. Okay, so what he found that in the eastern coast of South Africa, somewhere here. Okay, so I'm writing Mesosaurus by M. Okay, somewhere here he found the fossil and also in the western coast of Africa, okay, somewhere here, he found this fossil. He found the fossil of Mesosaurus. Okay, so Mesosaurus existed in these two parts of the world. Okay, so now since Mesosaurus is a freshwater reptile, so this reptile will always live in freshwater and not in your seawater or salt water or saline water, right? So that means there must be some fresh water, okay, between these two, between this part South Africa, between the eastern coast of South Africa and the western coast of Africa, there must be some freshwater source where the Mesosaurus existed. Okay, now we see that there is ocean. Okay, there is no fresh water, we are seeing just the ocean. So what is happening is that maybe there was a point of time that these two continents were connected to each other. Okay, there was no ocean in between them, so these two continents were connected to each other. That is why these two fossils were observed in this part and this part. Okay, so this was his second evidence. All right. Okay, the third evidence, you can go back in, you can go back in the video and pause the video and you can note down the evidences. Okay, it got erased. Okay, so third evidence I am writing. Okay, so third evidence is mountain ranges in northeastern US and northern Europe. Okay, mountain ranges in northeastern Europe, northeastern Europe, sorry, it's not Europe, northeastern United States, United States and northern Europe and northern Europe. So what he observed is that he observed same types of rock and same age of rocks. Okay, what he observed? He observed same type of rocks in the mountain ranges. So he observed same types of rock in the mountain ranges of northeastern US and northern Europe, and also he observed that the age of those rocks was same. Okay, same age of rocks Now this is geologically unlikely, very unlikely. Okay, so this thing is geologically unlikely. This is geologically unlikely unless these two mountains are one single mountain range. Okay, are you understanding? You see, northeastern US somewhere here. Okay, mountain ranges. Okay, mountain ranges of northeastern Europe, sorry, northeastern US and northern Europe somewhere here. Okay, so what he observed is that these two mountain ranges had the same type of rock and the age of these rocks was same. Okay, so this is geologically highly unlikely. Okay, until and unless these two were same mountain range. Are you getting it? So what happened was, maybe there was a time when these two continents were close to each other or were directly in contact with each other, and these mountain ranges were a series of a single mountain range. So what happened is that there was separation with time, and then these two mountain ranges, they got separated. Okay, and because of which they had the same type of rock and same age of rock. This is having this same type of rock and same age of rock in two different places is geologically very unlikely, but this can happen only when these two were previously one single mountain range. Okay, so that this evidence showed that maybe these two continents of Europe and North America that is present now, they were together at one moment of time. Okay, so this was his third evidence. And finally, last evidence that he gave, evidence 4, is he went on to look at the past climate data. Okay, past climate data, and what he found is that glaciers, okay, so glaciers are always moving. Okay, plus past climate data, glaciers are moving. Okay, glaciers always move, and while moving so they leave some evidence. Okay, glaciers always move, but while moving they leave some evidence. What evidence they leave? They leave evidence over the rock. Okay, over the rock on which they are moving. Okay, so they leave evidence. Those evidences are called as glacial striations. Okay, glaciers move, they leave evidence over the rock, so these evidences are in the form of glacial striations. Glacial striations. Glacial striations. Okay, and these glacial striations were observed in tropical rainforest of South America and Africa. Okay, so the glacial striations were observed in tropical rainforest of South America and Africa. Okay, all right. So but as we know, glaciers, these two are very hot parts. Okay, and glaciers can never exist in these two parts, right? Because glaciers will always occur in, or always found in, cold parts, right? So since there was glacial striations found in these two parts, so there may be some time in past that these two tropical areas near the earthquake, there must be they must be somewhere near the they must be somewhere near the poles. Okay, and because of which there was glacier. Okay, and on top there was glacier on top of the rock of bed of rock. Okay, and the glaciers moved and they left these evidences. Okay, and as the time progressed, so these two continents separated and they are now near the equator, right? So this was the fourth evidence that he suggested. Okay, all right. Okay, I hope the evidences are clear. And then there was again one more evidence that he found that so by in the books of geology it is there that bituminous coal is formed because of plant origins. Okay, because of pressure, because of under constant pressure, temperature, and because of changes to the plants. So bituminous coal is they are obtained because of plant origins. Okay, and mostly the coal they were mined mostly in the cold region. So and so for example, let's say Antarctica is having lots of coal deposits. Okay, so this coal deposits that Antarctica is having, they are of bituminous coal. Okay, so since bituminous coal is of plant origin, and the continents of the rainforests in the continents of South America and Africa, they had these grasses, right? Since it's a rainforest, there will be lots of grasses and trees, so it's a plant origin. So hence this was also indicative of the fact that the earth was a single continent. Okay, as bituminous coal was found, okay, in these parts, okay, in these parts of the in most parts of the Antarctica, and the bituminous coal is generally of plant origin. Okay, but if we see now, there is no there is obviously devoid of plant life, okay, like the plants and grasses in Antarctica. Okay, so what happened is that earlier there is rainforest in your Africa and South America. Okay, so it is highly likely that these rainforest from this rainforest of South America and Africa, this bituminous coal has originated. Okay, and since there was glacial striations in these two continents, so it may be that these two continents were directly in contact with Antarctica and they were near the poles. Okay, but as the time progressed, they separated in these two continents, they came near the equator, but at earlier, okay, at very past, so this may be the case. Okay, so this is one of the evidences. Okay, so that was given by Alfred Wegener. Okay, so these are some of the evidences, okay, which were presented in support of this theory. Okay, but why the theory failed? Okay, I have given you that part also, but why the theory failed? Okay, the theory was not accepted by the modern scientists and researchers because it didn't explain anything about the way how the continents moved and the pattern in which the continents moved. Okay, so the theory didn't explain anything regarding the pattern of the movement and the mechanism behind the movement of the continents. Okay, so hence this theory was not widely accepted by the researchers and scientists, and then they went for another theory which is in modern era we call that theory as the theory of plate tectonics. Okay, so we'll be covering that theory in the next class. Okay, so I hope you are clear of what was taught in today's class. Okay, just go through your notes, okay, to understand even more. Okay, and you can pause the video in between and you can note down the important points that I am mentioning, okay, in the video. Alright, so if you have any doubts, you can obviously ask me. Alright, and thank you for your time. Have a great day ahead.